Chapter 6. The Sixth Law of Zero. Water. Water is becoming so scarce and precious that many say it's the new oil. Demand for water will grow with population, urbanization, and wealth, taxing traditional fresh water supplies while also polluting them. But there's hope. To see how that hope could play out, let's look back into the mid to late 1800s and the world's obsessive need for bird guano. Yup, we're going to talk about bird poop. Economist Thomas Malthus famously wrote in 1798 that, essentially, we were all doomed to die in a famine because food production couldn't keep up with population growth. Jonathan Swift's epic satirical essay, A Modest Proposal, said that because all the poor kids were going to die and rich people would be hungry, why not just feed the poor kids to the rich people? Then bird poop came to the rescue. Once the wonders of nitrogen-rich guano were discovered, the world's farmers had all the fertilizer they needed. Poor kids, and everybody else, were safe. But the competition for guano became fierce. So fierce, the U.S. passed a law during the Lincoln administration that promised the protection of the U.S. Navy to any citizen who found an island covered in bird guano that could credibly be claimed as a U.S. possession. Spain went to war with former colonies Chile and Peru in the mid-1860s over the guano-rich Chincha Islands. Chile and an alliance of Bolivia and Peru fought a 5-year war over the Atacama Desert, which had become covered with especially nice, dry bird poop. By the late 1800s, bird guano was running out. Pessimism about the food supply set in again as the 20th century began. Then Fritz Haber came along and, in 1909, invented a process that literally pulled nitrogen out of thin air, and Carl Bosch made the process scale. The food crisis was over. All that was needed for the Haber-Bosch process was a catalyst and lots of energy. The law of zero for energy should now allow for some of that same sort of magic with water. Water won't be pulled right out of thin air in great quantities anytime soon, but that technology is under development. One group won a $1.5 million X Prize by developing a generator that can be used in any climate and can extract at least 2,000 liters of water a day from the air, at a cost of less than 2 cents a liter, using entirely renewable energy. Cody Friesen, founder of Source Global, says 1 to 2% of the world's carbon footprint comes from mass purifying today's water. That carbon dioxide goes away when water is drawn from the air and is purified at your doorstep by the sorts of solar-powered source hydro panels he produces. Friesen's company has its naysayers, who believe the technology will never be inexpensive enough at scale. Think of all the time and effort people in developing countries could save if they didn't have to trudge miles to and from wells every day. Then think about what they can do with all that newly available time. By the time the future perfect arrives, anyone near a body of salt water will certainly benefit from technology breakthroughs. Desalination has always been possible, but prohibitively expensive because of the energy costs, whether done by filtering out the salt through osmosis or by evaporating the water and leaving the salt behind. But cheap energy makes desalination more plausible at a time when many cities are getting desperate. Cape Town in South Africa was on watch for day zero for a year. Day zero being when water for the city of 4.3 million people would run out, even as limitless salt water from the Atlantic Ocean sits cheek by jowl with the city. Slashing water consumption in the city by 50% bought time, and rains eventually began to refill reservoirs. Chennai, a city of 11 million that is India's 6th largest, hit day zero in mid-2019, even though it's on the coast of the Bay of Bengal. Chennai has been in a state of emergency ever since. Dubai, a city of about 2.5 million, is so desperate that it's explored the possibility of towing a 100 million ton iceberg to the city's shore from 5,500 miles away in Antarctica. San Diego has already opened a $1 billion desalination plant that provides water for about 300,000 people, and there are some 20,000 desalination plants around the world already that provide water for about 300 million people. The cost of the desalinated water is twice as high as the cost of water from other sources. But remember, energy costs are following a law of zero. If costs fall far enough, suddenly desalination isn't just plausible at scale, it's positively economic. Many states and countries will transport the desalinated water well beyond the coast. Already, California uses about a third of its energy output to transport water from the wet northern part of the state to the arid south. So the law of zero for water has the potential to create the kind of effect air conditioning did in the early 20th century. At the time, the American Southwest, for instance, was considered barely habitable because of the heat. Then air conditioning tamed it. Now, cities like Phoenix are among the fastest growing in the country. Just imagine the possible population shifts if water becomes abundant almost anywhere within striking distance of an ocean. Water reuse will also become far more common. Taking effluent from wastewater plants and treating it to drinking water quality has long been possible, but hasn't been done at any scale because of the yuck factor. People can't fathom drinking water that came from raw sewage, even though it's perfectly fine in every way. But the increased demand for water as climate change dries up many areas, including the American West, will push water reuse into the mainstream. We'll have no choice. Water reuse will become a major factor in agriculture, industry, and human consumption. Technology advances will let water reuse happen all over the place, not only at centralized facilities, but in small, distributed ways, much as the gains we detailed in the law of zero for energy allow for microgrids. For instance, the Janicki omniprocessor generates electricity and water simultaneously, while also attacking sanitation problems in developing countries. 3 wins at once. The device is a sort of self-contained plant whose input is a slurry of raw sewage. The machine boils the sewage, producing fresh water. Waste from 100,000 people would provide enough water for 43,000 of them. The residue from the water, now dry, is then burned to boil more sewage and to produce electricity. The fire produces ash that has no odor and no microbes that could cause disease. The ash can be used as a soil amendment or additive for construction material. If water fades as an issue, political tensions would drop in many areas. China is currently damming up the Mekong River, claiming much of its water and angering those the river feeds throughout Southeast Asia. Israel and its Arab neighbors are arguing over the water from the Jordan River. There are rumblings of war between Egypt and Ethiopia over a dam Ethiopia has nearly completed on the Nile. Southwestern states in the U.S. tussle over the Colorado River, which is tapped so heavily it runs dry before reaching the sea. More access to more plentiful water would drastically ease concerns and tensions. Where there's abundant water, along with the energy that comes from that law of zero, there can be food. So all sorts of possibilities arise. For instance, people are experimenting with vertical farming, growing food on the sides of tall buildings, or using artificial photosynthesis to grow food in warehouses, so city dwellers could have access to fresher produce transported over shorter distances. That kind of controlled indoor farming could also produce the sort of radical improvement in efficiency for water usage that Lovins, the author and conservationist, foresees for energy usage, and farming accounts for 80% of water consumption in the U.S. In any case, just as electricity no longer needs to tie into an elaborate grid, water could be produced independent of the massive municipal pipeline projects we rely on now. In the future perfect, the basics of life will be available everywhere, even to the far corners of the earth.